something is wrong with Mercury. If we trust the latest insider data, the James Webb Space Telescope has found evidence of a past with life forms on this unassuming planet. But that's not all. Mercury may be completely different from what we thought. It may be hiding things that have been right in front of our eyes all along, and we just haven't seen them. Exploring Mercury is considered almost impossible and dangerous, both for a good reason, which we now finally know. Hidden in the very center of our solar system is a planet that hardly anyone has had on their radar when it comes to fantastic discoveries in our solar system. Based on recent observations in which the James Webb Space Telescope was also involved, scientists suspect that Mercury has a secret that it has been able to keep well hidden from us until now. Mercury is a rocky planet slightly larger than Pluto and significantly smaller than our Earth or Mars. This world was actually considered far too hot to harbor life or any kind of vegetation. But then research discovered water deposits on Mercury, and our image of this world is slowly changing dramatically. It seems as if we need to completely rethink our solar system. Mercury is not the boiling hot world you would think. Little Mercury would be the hottest planet in the solar system. Theoretically, this mysterious world should also be a real furnace, but that's not true. Mercury is the planet that is clearly at the top of the list of planets closest to the Sun. Its distance from the Sun is only 58 million kilometers compared to Earth's 150 million kilometers. Nevertheless, the hottest planet in the solar system is Venus, and though Mercury's climate is also hot, the much smaller Mercury is temperate compared to Venus. Thanks to its small radius around the Sun, Mercury is the fastest planet with an incredible speed of 47 kilometers per second. The planet completes a full revolution in just 88 days. This speed is probably due to the gravitational pull of the Sun. Mercury has even more fascinating properties. Mercury's surface is characterized by a varied landscape. Numerous craters tell the story of an eventful past and geological activity that could even resemble that of Earth. Large basins, such as the Caloris Basin, which measures over 1,500 kilometers in diameter, are striking landscapes on Mercury. Between the craters are vast plains that were probably formed by ancient volcanic activity. Some regions show signs of shrinking, indicating that the planet has cooled over time as the mantle contracted. Stunning landscapes of steep cliffs and towering precipices have formed. Scientists call these structures, which can be several hundred kilometers long and up to 3 kilometers high, lobate scarps. Other typical Mercury landscapes are the hollows, small bright depressions that have probably formed through sublimation of elements such as sulfur and potassium. At its poles, Mercury has craters that are permanently in shadow and thus keep it cold enough to store water ice. This discovery resembles a small miracle, as researchers long thought that Mercury was far too warm to store water there permanently. The fact that there is water on the small planet shows us that we underestimated Mercury. If we look at the actual temperatures on Mercury, it quickly becomes clear that we are looking into a world of extremes. Nevertheless, Mercury is by no means a boiling hot hell like Venus. Temperatures fluctuate and peak at up to 427 degrees Celsius during the day but drop to around -173 degrees Celsius at night. Scientists attribute these extremes to the fact that the planet has almost no atmosphere to store or distribute heat. Venus, on the other hand, has one of the densest atmospheres in the solar system. A greenhouse effect is formed here within a thick shell of carbon dioxide, which heats the planet to temperatures of up to 467 degrees Celsius day and night. Mercury is quite different, and the ice shows that there may be regions on this planet that are temperate in terms of temperature. This raises the exciting question of whether it is conceivable that life could exist in such marginal zones, in shady craters or beneath huge cliffs and rocky outcrops that offer protection. The discovery of an alien world is astonishing. Who could have thought that the Greeks had already succeeded in discovering this comparatively tiny world in 265 BC? On the scale of our solar system, you have to imagine Mercury as a pin size that is actually only visible to simple telescopes when it passes in front of the Sun. It was the Greek astronomer Timocharis who was the first to record the planet's position in the sky. However, it was not known how he discovered Mercury. Over the centuries, various civilizations made observations and records of Mercury, but it was often difficult to study the planet accurately due to its proximity to the Sun. It was only with the advent of modern telescopes in the 17th century that astronomers were able to make more detailed studies and better classify Mercury for what it is, the closest of the 8 major planets in the system to the Sun. In 1631, the French astronomer Pierre Gassendi was the first to describe a transit of Mercury in front of the Sun, and he calculated the planet's orbit. In 1771, the German astronomer Johann Hieronymus Schröter studied the rotation of the planet and made a blatant mistake that led to a misconception for a long time. Schröter thought that Mercury had a bound rotation to the Sun, similar to the Moon to the Earth. It was not until the middle of the 20th century that it was proven that this was not true. Mercury rotates extremely slowly on its own axis but races quickly around the Sun, which led to the erroneous image of a bound orbit. In 1859, something even stranger happened. The French astronomer Urbain Le Verrier noticed that Mercury's orbit showed anomalies that could not be explained by the gravity of the other known planets alone. To explain these deviations, Le Verrier postulated the existence of a previously unknown planet between Mercury and the Sun, which he called Vulcan. Astronomers at the time searched for Vulcan for decades, and there were also several supported sightings of the planet. However, the existence of this world was never proven. In 1915, Albert Einstein solved the mystery of Mercury with his general theory of relativity. His theory explained that the gravity of large masses such as the Sun bends spacetime, thus explaining the anomaly in Mercury's orbit. This probably put the idea of Vulcan off the table for good, although the planet continued to fascinate science fiction writers in the 20th century. Anyone who loves Star Trek knows the pointy-eared Vulcans. It is a little surprising to hear that we've had something like an exact map of Mercury's surface since 1974. The images taken by the Mariner 10 space probe are legendary. The first Mercury probe revealed the smallest details on the surface of Mercury in unusually sharp detail. NASA's probe flew very close to Mercury 3 times. This resulted in the first ever close-up images of Mercury, the first time humans saw craters and landscapes, as well as the true colors of Mercury. Mariner 10 not only photographed Mercury in detail but also provided us with measurement data from the planet's surroundings. This showed that Mercury does not have a real atmosphere but only a thin exosphere of helium and hydrogen. The probe was also able to measure a weak magnetic field, which was quite a surprise. Until then, it had been assumed that Mercury had no magnetic field at all due to its small size. After the 1970s, Mercury became conspicuously quiet for a long time. NASA refused to send any more probes to this planet, and this caused some speculation. The reasons always given by NASA were that the probes to Mercury would be extremely difficult to build and navigate due to the gravitational pull of the Sun and the extreme conditions. A Mercury probe must be sturdily built and have a powerful propulsion system to prevent a probe costing millions of dollars from being accidentally swallowed up by the Sun. It was not until 2008 that NASA embarked on the adventure once again. The Mercury Surface, Space Environment, Geochemistry, and Ranging Mission, or MESSENGER for short, successfully opened the next chapter in the exploration of this planet. MESSENGER also put an end to rumors that NASA no longer wanted to fly to Mercury for a completely different reason. MESSENGER successfully entered Mercury's orbit in 2011, and by 2015 it had provided new insights into the planet's geological history, including exciting new evidence of volcanism, images of extensive lava plains, and evidence of water ice in the polar craters. MESSENGER's measurement data aroused the curiosity of scientists, as the data showed there could be far more to Mercury than we previously suspected. In particular, the evidence of the planet's turbulent past shows that Mercury was and is very active geologically. This in turn may indicate that we are misjudging Mercury's past. Some scientists believe that Mercury was once in a different position in the solar system and was then pushed all the way in by Jupiter's gravity. What if Mercury once stood in the habitable zone and possibly harbored life? Some of Mercury's landscapes are indeed reminiscent of a rocky world like ours or even Mars. Researchers suspect that a planet that developed so close to the Sun from the beginning would look very different. It is therefore possible that Mercury was once in the temperate zone. After all, James Webb is now to shed new light on precisely these questions. Thanks to the study of planets such as Jupiter and Uranus, we already have completely new impressions of the gas and ice giants. Scientists want to find out whether we now also need to rewrite the history of our solar system when Webb sets its sights on Mercury. The new space telescope will use special filter techniques that will allow it to scan Mercury around the Sun. The telescope is virtually predestined for this task, as it was specially built to capture even tiny exoplanets passing in front of their stars. In our own solar system, the tiny Mercury in front of the gigantic Sun is like such a small exoplanet. Webb can detect minimal fluctuations in light and thus clearly separate the light reflected from Mercury from the light of the Sun. If this observation is successful, we will have even more precise data on the chemical composition of the surface. Researchers hope that the scans will provide data on whether Mercury is really just a lifeless and inhospitable world or whether there may be structures and activities here that we have previously overlooked. If the telescope finds further evidence of water on the planet, it would be a sensation. The scientific community would then have to acknowledge that Mercury is a far more complex and mysterious world than previously thought. Click subscribe now, new exciting videos are coming all the time.